Hello chemistry students, this is Ms. Sotomayor. So I thought I'd make my own video lesson this time and show you how to calculate molecular and empirical formulas. So I have your workbook up here. So this is page 16 of your workbook. This is the problem set number 6 that you're going to be assigned to work on after the video lesson. And what you're going to do first is take notes as I go through the PowerPoint, and you are going to begin the notes on page 9 of your workbook. So it's lesson 5 in the workbook of molecular and empirical formulas. So let's get started. So how is percent composition used? So if I'm able to decompose compounds and analyze their percent composition by mass, then I can identify the molecular formula of the compound, and I can therefore identify an unknown. So pretty much I am taking a compound, I am breaking it up, finding how much mass per element I have in a compound, and then I'm able to determine the compound's formula. So what is a molecular formula? So as you can see here, a molecular formula shows the actual ratio of the elements in a compound. So here you have an example, C6H12O6. You probably all remember this from biology. This is glucose. And this just says that this particular compound, known as glucose, is made up of 6 carbons, 12 hydrogens, and 6 oxygens. Now the empirical formula for glucose is CH2O. C, only one subscript here, hydrogen 2 hydrogens, and oxygen 1. So can you guys guess what the empirical formula will be, or what is the empirical formula? Well, did you guess? Okay, so the empirical formula is the lowest whole number ratio of the molecular formula. So if I go back here, notice that if I take the molecular formula and I divide it by the lowest common denominator, which would be, in this particular case, would be 6, I can divide 6 by 6 and it gives me 1. I can divide 12 by 6 and it gives me 2. And then I can divide 6 by 6 and it gives me 1. So the empirical formula is the simplified version of the molecular formula. It's the lowest whole number ratio of the molecular formula. So let's do some practice here. So what would be the empirical formula for C6H12? So do you find the lowest common denominator? That would be what? 6, right? So if you divide 6 by 6 and 12 by 6, what is the empirical formula? Well, the answer is CH2. You got it. 6 divided by 6 gives me 1 carbon. 12 divided by 6 gives me 2 hydrogens. Let's try another one. This is benzene. It's a chemical that's widely used by the chemical industry, found in tobacco smoke, vehicle emissions, and gasoline fumes. It's also a toxic chemical. Exposure to it could increase the risk of a certain cancer known as leukemia. So in looking at this diagram of benzene, what do you predict would be the molecular formula for benzene? Now remember that the molecular formula gives you the actual composition of the molecule by counting how much of each element you have. So let's start counting. How many carbons do you see here? 1, 2, 3, 4, 5, 6. And how many hydrogens do you see here? 1, 2, 3, 4, 5, 6. So what is the molecular formula for benzene? You guessed it. It's C6H6. Now look at how the number 6 is written as a subscript. Remember, a submarine, written right there at the bottom. So now let's calculate this problem. If the molecular formula is C6H6, what is the empirical formula? So now we're going from the molecular formula to the lowest simple ratio, which is the empirical formula. So again, we find the lowest common denominator, which is 6. 6 divided by 6 is 1, and 6 divided by 6 is 1. So then the empirical formula for benzene would be just CH. All right, a couple of more practice questions. So what do you think would be the empirical formula of a molecular formula that is C6H8O6? So find the lowest common denominator of 6 and 8. What do you think that would be? And then divide by that, and what do you think your empirical formula would be? So the answer is C3H4O3. So what did you divide by? You divided by 2, right? So that's the lowest common denominator. 6 divided by 2 is 3. 8 divided by 2 is 4. And 6 divided by 2 is 3. Try another one. Now this one's a little bit trickier. If the molecular formula is CO2, what do you think the empirical formula is? Well, here's a little note. All ionic compound formulas are the empirical formula because they are always in the lowest ratio of ions. So as you notice, CO2 is already in its lowest ratio. Therefore, the molecular formula and the empirical formula are going to be the same. So in this particular case, the empirical formula of CO2 is, you guessed it, it's just CO2. All right, for number 5, we have to do a little bit more math here. We have to use our periodic table, and we have to remember how to calculate the molar mass of a compound. So I'm going to show you how to find the molecular formula when they give you the empirical formula and the molar mass. So in this particular problem, it says that the empirical formula is CH3 and the molar mass is 30 grams. And they want you to find what the molecular formula is. So there's a couple steps that I want you to follow. Step 1 is asking you to first find the empirical mass of CH3. Then you should calculate how many times does it go into the molar mass, and step 3, multiply the empirical formula by that number. So let's take it step by step. Okay? So what is the empirical mass of CH3? So I have to look in the periodic table, and the mass for carbon is 12, and the mass for hydrogen is 1. But there's 3 hydrogens. So the mass of carbon, 12 plus 3, gives me 15 grams per mole. So that's the empirical mass, right? So I take the empirical formula and I find out what the empirical mass of that is. And then it asks me how many times does it go into the molar mass. So in this particular case, you have to take the molar mass, 30, divided by what you calculated the empirical mass to be, and it gives you the number 2. So that's how many times it goes into the molar mass. So then you multiply the empirical formula by that number. So they give you the empirical formula, which is CH3. You multiply it by 2, which is how many times it goes into the molar mass. So 2 times 1 carbon gives you 2 carbons. 2 times 3 hydrogens gives you 6 hydrogens. So the empirical formula is C2H6. Okay, let's try another one. So what about this one? A compound has an empirical formula of C2H5. Its molar mass is 58 grams. What is the molecular formula? So I'm going to try to solve this one for you here. Oops.